Today we are going to explore the different ways that heat can be transferred. We've talked a lot about energy. We've talked a lot about how there are different forms of energy. Can anyone think of any off the top of their head? Syra, what's one? Nuclear energy. Alita, what do you got? Chemical energy. Rebecca? Sound energy. Connie? Gravitational. Chloe? Elastic. Excellent. Rhea? Mechanical. Ariel? Thermal. Samantha? Light energy. Yeah. Magnetics one. I don't think we said that yet. Libby?
Did anyone say sound energy?
I think Rebecca did. What about gravitational? Connie's a good one. All right. So what's going to happen today? We're talking about heat energy and how it can move and go from one place to another. So what's going to happen is I'm going to set up 3 different experiments that you are all going to do. And each experiment is going to represent a different way in which heat moves from one place to another, from one state of matter to another, and from one source to another. What you're going to be expected to do is do the explain game at each station. So, we set up? Go. First experiment involves some boiling water. You each have a beaker at your table with lots of different things in it. What are some things you can see in there? Sorry, what's in there? A fork is in there. What else is in there, Alita? A weird stick thing. What color is it? Brown. Okay, this is very hot. Please don't touch.
Oh, wait. Please don't touch. I must get my binders out of the way. There's a plastic. What is the plastic? I'll put it on the chair. Everything's in there.
Well, no, I'm not boiling water. Guys,
oh my god, it's boiling water.
You will. Leave it, please. Don't touch it for 10 minutes.
Did I touch it? I didn't touch it.
Okay. You now have a beaker full of hot water with different different things in it. Leave it for 10 minutes. What's going to happen is I'm going to explain the lab while it's getting itself set up, and then you guys are going to explore. You are going to be expected to do something for each station, for each lab, each demonstration or experiment. That's a better word choice. We're going to play the explanation game. So, you are going to have a sheet with 3 tables and 3 sections. You're going to be expected to do something in each section. Chloe, could you hand these out, please? Thank you. In the first section, you are going to sketch it. You can sketch this in the give reason section or the name it section. It doesn't have to be beautiful artistic work. It just has to be a quick sketch so you can look back on it and go, oh yeah. Then, in the name it section, you're going to write down things you notice. What do you notice going on in this experiment? What's happening? What do you notice?
I haven't done it yet. I don't know.
In the explain it section, talking amongst your peers, why do you think it is that way? Why do you think things are happening? It's very hard not to walk around the classroom. So talking amongst your peers, try and talk about what you see happening. Why do you think this is happening? And then, the extra challenge part, give reasons. What is the scientific explanation or reasoning? Do you have the scientific explanation or reasoning yet? No. The goal today is for you guys to try out a few experiments and then eventually find the reasoning and explanation behind what is happening in front of you. So you will be expected to do this for each experiment. Now, the last experiment I'm actually going to do periodically. I'm going to do the first part now. So this is going to be experiment number 3. Flip over your page. I have a bottle of blue water and hot water.
Oh, cold water? No, I did not. Cold hot water. What was that? That was like Carnegie.
red water is based on just watching me just now, Samantha? Hot water, yes. Here's what's gonna happen. I'm gonna do this one twice actually. The first time, I'm gonna put the cold water on top of the hot water bottle. The second time, I'm gonna do the hot water on top of the cold water. All I'm gonna do is set it up. You guys have to sketch what you see and do the name game, or the explanation game. You have to sketch it, write down things you notice, and then start discussing with your peers. What do you think is happening? Why do you think it's happening that way? And then by the end of the lab, I'm going to show you 3 definitions of heat transfer, and you talking to your peers are going to connect them to the experiments you just saw. Syra.
For the sketching, are we going to get a sticky, or do we just...
I'd like you to draw it on the paper. So, now, let's start out by doing some critical thinking. What do we think, if you've already seen this, please don't give spoilers. What do you think is going to happen when I put the blue on top of the red? What do you think, Libby? Do you think they're going to mix? Or...
Probably, but also the red's going to overflow because they're very full.
Oh, interesting. Okay. So sketch it, and in this one you're going to have blue on top of red for the first one.
Okay.
You ready?
We sketch it.
If you flip it over on the back, there's a lot of blank space. You can use the bottom part to sketch it.
So we sketch like how it is.
Blue on top of red, and then you can do a little arrow to show what's happening after. I'm going to try not to make too much of a mess.
Okay. Wait, can we draw a bottle on top of the
Yeah.
Oh, we draw it right now or after you do it?
You can do it while I put it on. I'll call you up a few at a time if you want to come see it. Actually, no. But you'll be able to see it just fine from here. Okay. You ready? I might spill a little bit of water. Hopefully I don't.
We'll probably overflow then.
Set up. I'm going to move this out.
I can watch. Actually, I can. What? That is so cool.
What's happening?
I think
Nothing.
they're not mixing.
They're not mixing?
Wait, are they? Yes, they are. They are mixing.
Are they?
Yeah, they are. The blue's
What's
going
happening?
into the red, but the red isn't going into the blue because the blue is above the red. So or is it?
No,
No,
there's a little bit of red.
There's some stuff going on here.
There's some stuff going up. Can I see? Is it supposed to look?
Yeah. Stay at around where Rhea is so you can stay out of the camera angle. But what's happening? What do you see?
Oh my god, it's turning.
Oh, but only the bottom one is turning.
Oh my god.
Yeah, because the
Whoa! Only the bottom one is.
This is a lot bigger
Turning
than
All right, you have a tech challenge now. Talk amongst your peers. Sketch it. What do you notice? What's happening? Why do you think this is happening?
So
Can you give any scientific reasonings?
the blue one is turning purple, and the blue one isn't really because the blue's flowing with the red. But the red is
I know, okay, I know.
because the blue goes down. But gravity makes it like. Yeah, gravity makes like.
Oh yeah.
No, gravity
And in the beginning,
the red's just coming up. Gravity forces things down. But the gravity will go up. Yeah. Yeah. No, but it is gravity. Because gravity makes it go down in the first place.
Okay, wait.
Yay. I like it purple, but not that purple. Actually, I like that purple.
Okay. You had a chance to go through the explanation game for the first part. Now, at each of your tables, you have a beaker full of hot water and different things within it. I want you now to try touching each of the tops of those things in the beaker and talk to your peers.
I want to touch it too. And then it turns hot. Too far away. This still has water. No, this one's cooler. This one is cooler.
This is called the heated spoons experiment. What do you feel? about this one?
Yeah.
Hot and cold.
Metal does though. That's why I'll do it.
Was that experiment 3?
That was experiment 3.
Okay.
Oh, I thought we were supposed to.
For experiment, for what?
For I know. I thought this was I know.
For name it? Yeah. What do you notice? Talk to your peers. What do you notice happening? What do you observe? Can you explain it in some ways? Kaylin, what do you observe?
I observed that the blue from the blue water went into the red.
Nice.
Not the red into the blue.
What about what's going on with experiment 1, the heated spoons?
Well, in that not everything was hot. Just
Not
like,
everything.
Mainly like the metal stuff.
Interesting. I think that's something you should include in
Oh, was that
you're noticing it. Okay? So for give reasons, what's going to happen is at the end of class, I'm going to show you the definitions for 3 forms of heat transfer. And amongst your table, you're going to try and connect those, those terms to the 3 experiments you just did. Why do you think it's happening? What do you think is happening and why? Share your observations with the peers. You might have half an idea and they might have the other half, and you can connect them.
Everything in there is a solid.
Metal just transfers energy.
It is a solid. Kaylin, what is it resting in?
Water.
In a liquid.
That's a liquid. Yeah.
Yes.
We're not even on the second one.
Now, experiment 2, I'm going to send you up table by table. Okay, this experiment's called black and white. I've had 2 pieces of paper under a very hot lamp for the past 10 minutes or so.
Oh.
In your tables, I'm going to send you to the lamp to feel the white and the black piece of paper. And again, in your tables, you're going to do the explanation game. So, you're going to ask yourself, are there any differences in the feel of each? Why do you think that is? Okay, what's going on there and why do you think it is that way? So, can I have Connie's group go first to the lamp right there? Yes. Do you want the explanation game part of it, or do you want, it's called heated spoons.
Was that number 1?
Yeah, experiment number 1 is heated spoons. This is actually experiment number 3. So when you guys are ready, you guys can go to the lamp section. Or Libby's table, are you guys ready to go to left? Okay, so go to the lamp station.
Yes.
Okay, so wait till Connie's group's done, then you can go. Don't forget to sketch your station that you're at.
Oh, I gotta sketch it. We already did the heated spoon.
Pardon?
That's the one we just did. Number 1.
Alright, Ria's group, go ahead. And then remember, explanation game, talk amongst your peers. What do you think is happening? What scientific reasoning can you use for it? The stick thingies warm up?
Yeah.
Yeah, there is. There's a fork and a knife.
All right, while the water's still hot, I'm going to do experiment number 3. This time, I'm going to have the hot water on top.
Oh, wait.
So,
What?
I thought this was number 3.
yeah, I'm doing it twice. Last time we did it with the cold on top. Now I'm going to try it with the hot on top and see if there's a difference. Libby asked it. She said, I wonder what will happen if the hot's on top first. So, what do you guys think will happen? You think the same thing will happen, Paige?
I think both will go on the
I think they'll both.
Do you think the cold will go up, Samantha?
I said that too.
Kaylin, you think that too? Alrighty.
No.
Do you guys want to find out?
Sure.
The first one was cold on top, right?
Let's go.
Okay, I'm going to remove it.
What happened? Neither mix.
What was your thesis, Alita?
So the hot water, like the molecules are moving apart, making it cold.
Oh.
Hotter and hotter is closer to becoming gas,
So you think the hotter one's closer to becoming gas, so it's moving more. So because it's moving apart, the cold water will move up into it. Well, that means it'll turn purple, right? Because it'll mix.
Yep.
Layla, what do you think?
I don't know. It doesn't seem like much is.
Yeah, is anything happening?
Not really.
No, it is. The hot water is turning pinkish, like purplish.
Is it?
Yeah.
Hey, you're in the camera now, by the way.
Oh no. No, it's not. They're not changing.
Wait.
Oh, maybe Alicia's right. And since it's closer to becoming gas, it's
Tell you what,
it's a map.
why don't we leave it for a minute while you guys, Kaylin's group can go do experiment number 2.
Why would the blue be coming up?
Why would it, Amelia? What do you think?
Because like if the red one's like becoming more of a gas, then how does that? Why would the blue one come up?
Because it's not moving into a gas state, right? Because it's cold.
Yeah.
Is anything heating up the blue?
Because the red moving into the blue, since the blue's full, it would like sort of push it out. Because the red milk is like a little bit out, and then the blue goes up to the red.
Yeah.
I don't know.
Like maybe
Because
it's
liquid
like the hot water is
opening up the
blue water, so it's coming up.
Right.
Just saying the same.
It is just staying the same. Chloe, what do you think's happening?
I don't feel any difference.
No?
Like I don't feel any difference. Like I feel it.
Yeah. It should be hotter.
The black one? Why should the black one be hotter?
Because there's heat.
Black absorbs heat. Where is it getting the heat from? Interesting. I think you guys could do that. Right, definitely write about that in your explanation game. Amal Stable, you haven't done that yet?
No, we're not even done.
Okay.
I still I'll put down that the black red water. That's how science should be.
I feel it.
Yeah, it is hotter.
It is
Black one
hotter.
is warmer in the white
You guys
one
are just
is
weird. You felt it, but you're not weird.
Yeah.
They feel it.
You just need to like. There's a tiny difference. For this one, explaining the metal is able to. Now I just remember about that thing about colors because I watched the I remember.
What about colors?
Would you
What
the colors like I don't know, but like I just remember like black. It's like hot because it absorbs the light and stuff. Where it's like you know how on a snowy day when it's really sunny, all the light like reflects like a little light into your eye.
Because, like, why do you get a sunburn when you go skiing?
Because it's white. All of it like it's really sunny. Then why?
Interesting.
So anything happening?
So check in. Anything happening with the water here?
No.
No. Did that surprise anybody?
Yes. No. Yes.
Well, it's kind of opposite of some people's hypothesis, right? Amelia, what do you think?
Wouldn't it be because like the blue went into the red
gets more and more heat into it, what do the atoms start doing? Ariel, what do they start doing? Kaylin, they start moving, right?
Yeah.
Interesting. I hope so. You included that in your.
I was watching the NHA panel, and like somebody was cosplaying as Stanky, and somebody asked them what their brain is like when they short circuit, and it was just like
Rhea, how's it going? What's your finger? What do you think about? Ah.
Are you sure?
Okay. Has everyone added the other sketch of the part 2 of this one? Sarah, if you guys are ready, you can go to experiment number 2, at least just to feel it.
No, that doesn't.
You have to draw both of them.
Yeah?
Oh.
Because I want you to show Connie that in the first one they mix, but in this one they're not mixing, right?
It is right.
Maybe how you do it anywhere. Are you done your explanation game?
Not really. Not very
Put them under the light. I have to say it's better than you.
Maybe. I don't really get it.
Give me the eraser back. Give it. Yeah.
How are we doing? Do you guys want a few more minutes to finish up the explanation game?
Yes.
We do a quick circle. See how you guys are doing.
It's across.
Do you guys have your science notebooks? Unfortunate. You haven't sketched anything, Kaylin.
It's on the other side.
Oh, lovely. Yes. They did. Mm-hmm. Yeah, but this one, are they turning purple?
No,
they both
the
turn
first
purple?
one only the red turned purple.
Well,
Gravity rents it.
it's the blue got purpley. It got sort of purple.
Oh my goodness. Full page of like this, and then I think it's like.
Kaylin, are you asking the eraser for
Yes,
answers?
because you write down no, and you write down
Oh,
yes,
it
you write down
always
it is
works.
certain, and you
It's
write down
so
maybe.
freaking
I know, you guys tried it on me earlier.
It's
Okay.
crazy.
It was wrong. What is?
Here's what's going to happen. I am going to now show you 3 scientific terms. Your job at your tables is to figure out which term fit which experiment that we just did. So, we went through experiment 3, we repeated it, and we found 2 very different results. Hello!
Talk to you later.
Oh, sure. Yeah. Miss Stevens, can I stop by your office at 3:40ish?
What's happening? What are we doing?
We are doing the explanation game,
Oh,
and
that
we
sounds fun.
saw this. Now I'm going to show the girls 3 different scientific terms, and they're going to connect it to 3 different experiments they just did.
Okay.
They don't know these terms yet, but they might have seen examples of them.
Okay.
Also, recordings that they got. So we did our explanation game, where we sketched it, named it, explained it. Now, we're going to give our reasons. So, let's share what we saw. What did you guys see happen in experiment number 1, heated spoons? What did you notice? What surprised you? What did you notice? Libby?
Well, the metal got hotter than all the other things, like these ones, and like, but not in this one. The thicker metal got warmed up,
Oh,
whereas
okay.
like, the glass and plastic and wood stayed room temperature.
And was it the top that was hot, or was it like closer to the water that was hot?
Closer to.
What do you think, Ariel?
I think it was the whole rod because the heat travels up to the top.
Interesting. Did you write about that and what you think is happening? I hope you
Heat
do.
goes up. Heat goes up.
Heat does go up. experiment over there. Connie, what'd you see?
The black paper turned hot because it absorbs heat.
Nice. Where did it get the heat from?
The lamp.
Cool. What kind of energy was the lamp giving off? And? What else was coming in? Light. Okay, and experiment number 3. Were we surprised by what happened the first time when the cold was on top? Kaylin. Good. What happened this time when the hot was on top? Samantha. Nothing happened. The hot water's still staying there. It's on top. So, let's see if we can connect these to some concepts. First term, conduction. Conduction is the transfer of heat through a solid or between a solid and another solid, liquid, or gas that it is touching. So, conduction of heat is like conduction of electricity. If something is exposed to something else that is hot, then the heat moves through it. So, talk amongst your groups. Let's do a think, pair, share. What do you think? Which experiment do you think reflected conduction? I put hot water in the beaker, and then we put everything in it and left it for 10 minutes. Boiling water. And then they had to wait and see. Very quickly. Am I in the way?
And plus when you touch the metal, and if you let go of it, somewhere else, it's way more.
So what do we think? Which experiment was conduction of heat? Which experiment? What do you think, Amal?
Heated spoons.
The heated spoons. Where did the heat move to from the water? Where did it move to, Paige?
All the way up there.
All the way up the rods. It moved into the rods. So, well, again, what happens when atoms get heated up, when they're exposed to things that have high energy or heat? What do? Libby? They can turn into gas. What else? What starts happening to them? They start shaking and moving, and eventually they'll start breaking bonds and flying out of liquids and into gas. Good. Convection. That's the transfer of heat through a fluid. So, you will get in your notebooks, this is a part, but if you're explaining it in the experiment, you can use these terms. Hello, Miss Dasko. It's a party. So, transfers of heat. Convection is for liquids. So, when we're thinking about hot water, where does hot water eventually go? It evaporates. So, where's it going? Up. And then when it gets up, think about your house. Where is the hottest part of your house in the winter? Is it the basement or is it the top floor? Top floor. What's your basement like?
Freezing.
It's freezing cold. Why is that? What's happening here? Kaylin? Heat travels up, cold travels down. So what do we see here? Okay, the last one, radiation. I think you guys got this one. So wait, which experiment was convection? I kind of gave it away. Which one? This one. Radiation, the transfer of heat in the form of waves. Heat waves, Rita, is that what you're saying? What else travels in waves? Alita. Light. Light travels in waves. Also sound. Yes.
And water.
So which experiment is this one? Black and white paper. Good. Okay. What's going to happen now is I'm going to give you some examples. These are something you're going to use in your notebook, your science package that you can put in. So, an example of conduction is heating a pot on a stove or my tea in my mug, the hot liquid, making my mug hot. The heat from the liquid is traveling into the mug. It's warming it up. Convection would be heating soup in a pot. When it's exposed to the bottom of the heat in your oven, the heat rises, the soup goes up, cools down a little bit, and moves in circular motions. It's actually how our magma and our earth moves, causes the earth's crust to move, because it's moving in a circle, pulling at our own earth's crust. Radiation, an example would be radiant energy of the sun or your body heat. So, to finish up, what you're going to do now is you have some Beat the Heat activities to do online. In your notebooks, I want you to get them out on page 12, I believe. You're going to be doing the definitions here and the household examples in your notebooks. And you're going to work on that. And then after that, you're going to do the Beat the Heat activity. And that will be your homework, but I have a feeling you'll be able to have time to finish it in class. Okay? Paige, if you're done with that, actually it'd be really helpful, girls, if you could take your beaker and dump out the water into the sink and put it back on the lab tray. Thank you. Shh. Okay, girls. So one thing I did want to mention that we didn't get to talk about earlier, we talked a bit about renewable resources, but who can tell me, well, that's kind of a dead giveaway. What form of heat transfer is used in solar panels, do you think? What form of heat transfer? Elita? Radiation. So solar panels use the energy from the sun to cause electrons to move, which makes energy and electricity. Now, I'm going to post, Amal, I'm going to post an article because I want you to consider the pros and cons of solar panels using radiation. It's very easy to say everything should be solar powered, but you should reflect on why. I'm seeing some really interesting articles about, I think it's Denmark that's making all of their roads solar panels, and they're making really interesting progress. But I think it's interesting, it's also important that you guys stay informed on the pros and cons of them. Okay? Sound good? I will post it up in the science news category of the homepage, and then I want you guys to look at it, and we'll have a bit of a discussion tomorrow on it. Sound good?
Okay, and is the science due tomorrow?
This, I have a feeling, no, I'm not here tomorrow, so let's have it due Monday.
Oh, when's the
Just watching the videos, too?
Yeah.
for math? When's the homework?
Homework for math, let's have it due Friday when I'm back. Okay?
Wait, what homework? Oh, yes.